Welcome back. So we are learning about the inductors. Okay, we did an example where the current waveform was given and we found out the voltage and the energy. Now a voltage drop across an inductor is given and we need to find out the current, initial and final energy stored and beyond those. Okay, so let's have a look at this example. So we have a waveform of a voltage drop across an inductor and we need to find the current, initial and final energy stored for the given voltage cross an inductor of 0.1 Henry, okay, with the IO0 is equal to 2 ampere. So IO0 basically represents the initial condition that at time equal to 0, the current flowing through the inductor is 2 milliampere. So voltage is given, we need to find the current. So let's first of all, let's write down the formula for the current. The current through the inductor is what? Initial current plus the actual current. So what is the actual current? 1 over L integral of voltage, right? Voltage drop across the inductor. Alright. So we are going to find for this case, so initial value of the current, we already know that this is 2 milliampere. Okay, so 2 ampere. So we will just plug in this number here. 1 over L 0.1 and we are going to integrate from 0 to t. So we have only a waveform from 0 to 2 second, right? So we are just solving for this case only, okay, from 0 to 2, okay, second. All right, so for 0 to 2 second, the value of voltage is always constant, which is basically 2 volt. So I will just put 2 here and integrate that. All right, so what will be this? 2 plus 1 over 0.1, that will give me basically what? 10, right? And what is the integration of 2 with the constant? So 2 will come outside and integration of a constant is t with the limit of 0 to t. Okay, so if we just simplify this one, that will become 2, 10 times 2, 20. Okay, and if you put up the upper limit will be t minus lower limit. Okay, like that will be upper limit t minus lower limit 0. So that will basically t minus 0 become t. So I can write this as 2 plus 20 t. Alright. So that is basically the voltage drop for this case. Alright, so let's move on. So this is the current, okay, for this given 2 to 0 to 2 millisecond. Okay, now if we talk about for time which is greater than basically 2 millisecond. Okay, so for that case, what will be the current again now? Okay, so again we need to write the formula, right? So for that case, current will be initial current. So initial current, now we are talking about greater than 2. So what is the current at basically 2? Okay, that will be the initial plus integration from 2 till t. What is the voltage for that case and its integration? This is important. What is the important thing here? We are calculating the current t greater than 2. So the initial current for this case will be at the initial point 2. Okay, plus the integration of the rest of the circuit. All right, now what we have here, voltage from greater than 2, okay, for this time interval. Okay, so here voltage is what? 0, right? So if voltage is 0, it means this whole terms will become 0. So we are left with what? Basically the initial current at 2 millisecond. So what is that? We don't have the formula, right? So what we learned that we have just calculated that from 0 to 2 millisecond, the current is basically 2 plus 20t. So using this, we can find exactly that what will be the current at 2, which is required here. So the current level at 2 will be basically what? 2 plus 20 times, instead of value of t, we will put our actual evaluation. So 20 times 2, 40, 40 plus 2, 42 milliampere. Okay, so basically current for t greater than 2 will always be 42 ampere. So if we try to plot this one, how it will look like? like from 0 to 2. So if I put t is equal to 0 here, okay, so 20 times 0, 0, 2. So basically at t is equal to 0, the value of current is 2. Then at t is equal to 2, the value of current is how much? 42, right? So basically we can get a straight line, okay, with the value of this one, okay. So this is basically the current. Then from t greater than 2, the value is always 42 milliampere. So basically if I go beyond 2, always the current will be 42 milliampere, just a straight line. So that will be the current waveform for this particular case. All right, now let's move on to the second part. Second part is find the initial and final stored energy. Okay, so the initial energy basically will be the energy stored, okay, initially, okay, at basically t is equal to 0. That will be our initial energy. Okay, so initial energy is basically what? Half L current, right? The formula of the energy is current square. So for this case, okay, we are going to calculate at t is equal to 0. So that will be half L. L is what? 0 0.1. Current at 0 square, right? So what is the current at 0? If you look at our formula, okay, like this is a formula that can give us, okay, the expression from 0 to 2 millisecond. Or at 0, what is the current here? 2, okay, like this here. If you put t is equal to 0 here, so 20 times 0, 0. So current at 0 will basically will be 2. So we can plug in this number here. So half of 0 0.1, 2 square. Okay, so if we just simplify this one, so that will become 4. 4 divided by 2, 2. 2 times 0 0.1. So that will just give me 0 0.2 of joule. Okay, so that is the basically initial energy stored by the inductor. Okay, initial. All right, now talking about the final energy. So final energy is basically energy at infinity. So same formula, half of L. L is what? 0 0.1. Now the current at infinity square. So infinity means that time is equal to t is equal to infinity. Okay, let's have a look at this waveform. Okay, so this like time is going beyond, beyond, beyond. So at t is equal to infinity, so we found that this value is always constant, right? Remains constant. So t is equal to infinity, the current will be basically what? 42, because that is always constant. So let's plug in the number. So half of 0 0.1, what is the current value? 42 square. And if we simplify this one, that will give us the answer of 88.2 joule. So this way we can calculate basically the final energy. For example, now if this is not given in the question, let's say we want to calculate what is the energy stored between 0 to 2 millisecond, for example. So what will be that? Now energy stored, okay, between 0 to 2 millisecond, so that will be half of L. Okay, current at the T2, what is T2 here? 2 milli square minus current at T1, what is that? 0 square. So we just need to plug in the numbers. So half of L, 0 0.1, current at 2 millisecond. Okay, so what is the current at 2 millisecond? We know that current at 2 millisecond is what? 42. So 42 square minus current at 0. Current at 0 is basically what? Current at 0? 2, right? So 2 square. So if you just simplify this whole answer, that will become basically 88 joule. Okay, or if you just look at the numbers here, like from 0 to 2, we can also find by subtracting the final minus the initial energy. Okay, so this is how we calculate basically uh, the energies for the inductors for the different time intervals based on the given. So for example, the voltage was given, we found the current. If the current is given, we can find the voltage. Okay, vice versa. The same formulas are there. By using those, we can get the desired results. Thank you so much.